Ever wondered how AI could help scientists crack the code of materials science? Imagine teaching a computer to read thousands of research papers, not just to see words, but to understand them. Like recognizing that germanium isn't just a name, but a material with specific properties. But here's the twist. Traditional AI tools designed for everyday language often miss the mark. They split scientific terms into fragments that lose meaning, like turning Lim-204 into Lim-2 and O4. It's like trying to read a recipe by splitting sugar into Sug and R. You lose the science. That's where Matter steps in. Think of it as a smarter way to break down scientific text, tailored specifically for materials science. Traditional tokenization methods, like BPE or WordPiece, split words into subunits based on frequency, not meaning. For example, germanium might become ger and eum, but ger isn't a chemical term and eum is just a suffix. The AI misses the real science. Matter solves this by using MatDetector, a tool that identifies key scientific terms. It's like having a guide who knows which words are critical, like graphene, perovskite, or Lim-204. Instead of fragmenting these terms, Matter keeps them whole, preserving their chemical meaning. Imagine training an AI on millions of papers, teaching it to recognize that ethylnediamine tetracetic acid isn't just a string of letters, it's a chelating agent used in medicine. The results? Matter outperforms older methods by 3–5% in tasks like generating material descriptions and classifying compounds. But here's the kicker. In precision tests, it jumped 8.9% over existing tools. That's not just a tweak, it's a game changer. By keeping terms intact, Matter lets AI spot patterns no human could, like linking perovskite to solar cell research or PDMS to flexible electronics. Why does this matter? Because AI isn't just about processing text, it's about unlocking new possibilities. With Matter, machines can now read materials science with precision, accelerating discoveries. Imagine AI scanning millions of papers to find hidden connections, like designing better batteries or materials for clean energy. It's not just faster processing, it's deeper understanding. If you're curious about how AI is reshaping science, hit subscribe. And let me know, what scientific field do you think needs a smart tokenizer like Matter? Thanks for watching. Hey there. Ever wonder how AI can actually understand the super complex words scientists use to describe materials? Like how does it know Pb is lead or perovskite is a special type of crystal? Today, we're breaking down a cool study that's changing how AI reads material science, because even tiny changes in how words are split can make a massive difference. Let's start with the basics. When AI reads a sentence, it has to break it into smaller pieces, like puzzle pieces, that it can learn from. This is called tokenization. But here's the problem. In fields like materials science, terms are super specific. Words like germanium or ethylnediamine tetracetic acid aren't just random strings of letters. They're chemical names with meaning. Traditional methods, like WordPiece or BPE, often split these words in ways that lose that meaning. For example, germanium might get split into German and eum, but German isn't a chemical term and eum is just a suffix. The AI ends up missing the real science. Enter Matter, a new approach that keeps those tricky terms whole. Think of it like a smarter way to split sentences, so the AI doesn't accidentally turn lead into Pb or perovskite into perovskite. The researchers tested Matter against other methods by feeding it thousands of scientific papers, even adding fake typos to mimic real-world messiness. And the results? Matter was a game changer. It nailed tasks like spotting material names in text, generating formulas, and answering questions about materials. One key metric, precision, jumped by 8.9% compared to older tools. Even when the team did stats tests, Matter's wins were rock solid, not just lucky breaks. But here's what really blew me away. Matter kept chemical terms intact. While other methods fragmented ethylnediamine tetracetic acid into confusing parts, Matter left it as a whole, letting the AI recognize its real-world uses. This means AI can now spot connections between materials more accurately, like linking perovskite to solar cell research or PDMS to flexible electronics. Why does this matter? Imagine AI scanning millions of papers to find patterns no human could spot. With Matter, researchers could accelerate discoveries, like better batteries, medical materials, or super-efficient solar panels. It's not just about faster processing, it's about deeper understanding. So next time you hear about AI in science, remember, it's not just about crunching numbers. It's about giving machines the tools to speak the language of materials. And Matter is helping them do that better than ever. Thanks for watching. If you want to dive deeper into how AI learns languages, check out our video on NLP basics. Stay curious, and I'll see you next time.